Hey, mathematicians. Just wanted to give you a quick overview of our assignment for this Wednesday and for math. So I want you to look at for the first one, it just wants you to count how many squares are shaded in each of these boxes, and then write the decimal and the fraction equivalent to each of these. So this number one is a little tricky because this shaded area goes halfway through some of these squares. So you're going to have to figure out how you can combine some of these halves to equal one whole. And some of it looks like there's a little bit of white showing, but don't worry about that. Those are supposed to be full squares. So don't let that fool you. But it will come out to a whole number. So you're going to write the decimal out of hundredths and the fraction equivalent out of hundredths as well. Number two is a little more straightforward. Count the shaded areas, write the decimal and the fraction equivalent. And then number 3 and 4, they would like you to shade in your own 5/10, and then write the fraction equivalent. I just said it. So, and then fraction equivalent is 70/100ths for number 4. I want you to shade in the appropriate boxes for that, and then write the decimal equivalent for that. Number 5, so we worked on this in part of our little checkup we did, but it wants you to write greater than, less than, or equal to. So we call it the NOLA theory, but if you are looking at the numbers, you're going to look at the whole number first, or the first, you go from left to right, and compare each number on each side of the box. Excuse me. So the first one is a 6, and this one's a 6. And then we have the decimal. We have 0. We have 0. Then we have another 0 on this number over here on the right-hand side, but there is no 0 on this side. But that doesn't matter, does it? So we know that we could add zeros to an infinite number of zeros, and it would still be the same number with all the numbers before it. So this one is actually equal to, this would be 6 is equal to 6. For B, we look at the 5, we look at the 5. Okay, so far they're the same. Then we go to the 10th place, which is 5 in this number. It's 5 in this number as well in the 10th place. So we move to the hundredths. This number has a 1. This number has a 4. All right, so right there, it's already showing me that this number here, 5 and 541 thousandths, is larger than 5 and 514 thousandths. Okay, so we would make our greater sign towards the 5 and 541 thousandths. All right, so good luck with that. Do the rest of those. So this page here is rounding, and it gives you some clues about what to do when you round. So it says round each decimal to the nearest 1, 10th, and 100th. Hint, look at the digit to the right of the place to which you're rounding. If it's less than 5, round down, which means keep it the same. If it's 5 or more, round up, which means go up one more. And here's the example they give. So the original number is 4 and 862 thousandths. So to the nearest 1, we're going to look at the 4. Okay. So then we look at the number to the right of the 4 to see what we're going to round to. So the 6 and the 2 right now we don't need to worry about. So we're looking at the 8. Is 8 greater than 5? It is. So the 4 would jump up to a 5. And then the rest of the numbers just go away or change to 0. So the rounding to the nearest 1 is nice because you just round the first number, and then the rest of the numbers go to 0. When we round to the nearest 10th, so I'm going to look at my 10th place, which is the 8. Okay. I'm not looking at the 4 right now. I'm just looking at the 8. Then I have to look at the 100th place, which is the 6, to see what I want to do to the 8. Is 6 greater than 5? It is. So that means my 8 needs to jump up. Let's look over here to a 9. Now the 4 stays the same because we're not rounding the one number. We're just rounding the 10th place. So their new number, so 4 and 862 thousandths rounds to 4 and 9/10ths when we're rounding to the 10th place. And you'll notice what happened to the 6 and the 2 over here. They just went away. They become zeros if you want, or they just go away. And then when we round to the nearest 100th, I'm going to look at my 100th place, which is the 6. And then what I want to do is look at the thousandths, or the number 2 here, to see what I do to that 6. So I ask myself, is 2 greater than 5? It is not. So we don't have to do anything to the 6. So really the only thing that happens if the number's less than 5, you just keep the same number all the way until the number you're rounding, which is the 6 in this case, the 100th. So our new number is 4 and 86 hundredths. You'll notice what happened to the 2 over here in the thousandths place. It's gone. It went away. Let me try to, let me see here. I always do this. Okay. So when I go to 48 thousandths, this is how we say the first letter A. Oh my gosh, that is huge. Ooh, is this better? No, that's not. And that's not going to work either. All right, how do I... Okay, I don't want to waste time here, but what I'm going to basically do is on this number, 48 thousandths, what I'm looking at here is the nearest tenth. I want to look at my, or to the nearest whole number. I'm looking at the tenths place, which is a 0, and this is a 0. So really, my first one is just going to be 0. Can I write that? Oh, I can. Okay, cool. So when I round to the nearest whole number, so, and for right now, that's what we're going to say. We could technically go keep, but I'm not going to worry about that. Okay. When I want to round to the nearest tenths place, I'm looking at my tenths place, which is a 0. Then I look at the hundredth place, which is a 4. Since that is less than 5, my tenths place stays the same. So really, it becomes 0 wholes and 0 tenths. And then lastly is I look at the hundredths place, and so I'm looking at the 4 here in the hundredths place, so I have to look at the thousandths to see what I do. Since 8 is greater than 5, I want to bump that 4 up to a 5. So really it just becomes 5 hundredths. So 0.05. So 48 thousandths rounds up to 5 hundredths. Okay, so do the rest of those. I don't know. Look at this thing. Oh, there we go. Okay. And then the last number before our challenge is complete the table below to show each fraction as a decimal, and each decimal is a fraction. So 3/4 of a fraction would be how much as a decimal? It would be 75 hundredths. So 3/4 of a dollar is 75 cents or 75 hundredths. 20 hundredths would be as a fraction 20 hundredths. So you'd write that there, and I can't do that. So go through and do those. And then if you want to go for the challenge, you can do number 8. All right, I hope that helps, and good luck today.